Ребят, микрофон подключен, да? Да. Уважаемые гости, мы начнем.
Dear guests, we'll start in just 2 more minutes. Please be seated. Come in.
Уважаемые гости,
Dear guests, I think we'll ease into it. But first, let me ask our technical team to put up a short video on today's topic, please. The Arctic and the Antarctic are the most remote and severe regions of the Earth, but that is exactly where the climate future of our planet is being formed. Day to day, we are seeing more and more signs of global warming. The average annual temperatures are on the rise. The ice is melting, permafrost is being degraded, the sea levels are rising. This all shows very clearly that climate change is underway. What awaits us in the coming decades? How can we prepare to the transformation in the natural systems? What opportunities can we get from this new climate reality? Will the Arctic seas become a new major transport route, and how will the global logistics change as navigation increases in the Northern Sea route? These and many more questions will be addressed by leading scientists and experts, participants of the International Science and Business Conference, Polar 2024. The Arctic and the Antarctic hold limitless potential for development of international cooperation, given the new climate challenges. A new wintering facility at Vostok, the free-floating station, Russian research center in Spitsbergen, the Svalbard, all enable major scientific studies and breakthroughs in technology. It's only through cooperation by the academias of different states will we be able to implement true fundamental projects for the humanity to be prepared and adapted to changes. The future depends on our cooperation today. Polar 2024. High aspirations and prospects for development in Russia and internationally. All right, dear friends, I'm glad to welcome you at the Scientific and Business Conference, Polar 2024. My name is Vladimir Nesterov. I'm a journalist, a host at Russia 24, a TV channel, and it's a great privilege for me to be part of this celebration of science. Before we start, let me invite on stage the students of the Polar School, great young men and women. Please come up, don't be shy, who graduated the Polar School recently. This school, under the Arctic and Antarctic Research Institute, does professional counseling in its domains. These are our future scientists, applied scientists, who are in high demand by the Institute, by our country, and by the global science as well. Please, let's give them a hand. Let me briefly tell you about their achievements so far. They did an internship at Ladaga, a scientific base. There were 4 tours where we interacted with the research fellows and scientists. I think they've decided on their future specialization already. To just want to join the school is not enough, actually. Selection started with 11 people. The course started with 11 people, but now 8 have remained until graduation, all in parallel with their regular studies at the school. So this was after hours. They did paleography, geophysics, the physics of ice, the atmosphere, hydrology, oceanology. They admitted that they didn't even know what the name of the subject meant at first. But let's appreciate the lecturers and teachers of the project as well for their patience in explaining what's what. So let's start. Guys and girls will now be receiving certificates of graduates of the Polar School. These are important documents that will get them enrolled in the university of their choice. So, to participate in the ceremony, I invite on stage the director of the Arctic and Antarctic Research Institute, Alexander Makarov. Now, diplomas are now issued to the students of 3 schools. Svetlana Druzhinina, 9th grade, school number 3 of Vsevolozhsk. Kondratenko Yelena, student of the 9th grade, school number 15, Vasily-Ostrovsky district of St. Petersburg. Manueva Ksenia, 9th grade, school number 15, Vasily-Ostrovsky district. Daniel Rudanov, 9th grade, Academic Gymnasium school under the St. Petersburg State University. Timofey Syomkin, 10th grade, Academic Gymnasium under the State University of St. Petersburg. Maria Sidorenko, 10th grade, the Academic Gymnasium under the St. Petersburg State University. Maria is a second-year student of the Polar School, and she won the Russian National Olympiad in geography. She intends to enroll with our institute. And then Fyodor Yevdokimov, 11th grade, school number 15, Vasily-Ostrovsky district. We congratulate the students on completing their course in polar sciences, and we're looking forward to seeing you in the next academic year. Thank you. Thank you. I'm really glad that you've taken a keen interest in polar research. I understand perfectly well that taking this course with the school will help you enroll with the university or our institute. But it still doesn't mean that you'll get employed with us or would like to get employed with us. Still, if you wish to do so, I can promise a very bright and intense experience and a lot of opportunities for self-actualization. we're always welcoming, and I really appreciate your interest in the polar sciences. We have broad plans and a lot of projects, which would be impossible without your future participation. You are our future. Thank you very much once again. Thank you, pals. You can be seated again. Well, Mr. Makarov, please take your seat on the panel. And I invite to join the panel as well Vladimir Lipinkov, head of Climate and Environmental Research Laboratory of the Arctic and Antarctic Research Institute. Please. Sergei Soldatenko, lead scientist, acting head of the Department of Ocean and Atmosphere Interaction at the Arctic and Antarctic Research Institute. German Leichenkov, Deputy Director General for Research, head of the Department of the Geology and Mineral Resources of the Antarctic Federal State Research Institute, named after Gramberg. And Mikhail Andreev, head of the Laboratory of Lichenology and Bryology of Komarov Botanical Institute of the Russian Academy of Sciences. Let's start with Mr. Makarov. Please, the floor is yours, and you have the first presentation. Thank you. I'd like to say a couple welcoming words as well. It's the second edition of this conference called Polar, and we appreciate your interest. We try to cover our achievements of the year, but most importantly, this is not just a showcase. Not just a showcase, but an invitation to engage in dialogue. I am confident that this platform will come to generate a lot of new ideas and new projects, new opportunities for cooperation and friendship. Thank you all very much for participating in our conference. We have a packed agenda for today. Usually, we make the conference coincide with the Day of the Polar Researcher, May 21st. But the guys are coming back to Murmansk just tomorrow, so we'll be welcoming them there. So we had to shuffle the dates a bit. My presentation is on the Antarctic. And we alternate the focus of our conference. Last year it was the Arctic, now it's the Antarctic, especially since there have been major developments. This January, we commissioned trial operation of the new wintering facility at the Vostok station, a major project that was put together really quickly. It's now staffed by our researchers and by our contractor staff from Zapsib-Gazprom, great builders. And by the end of the year, the station is due to become fully operational, meaning that the next milestone winter season for the Russian Arctic expedition will be supported by this wintering facility. It's an impressive structure. Its floor area is almost 3,000 square meters. It has 3 levels, and it can accommodate up to 30 scientists during the summer and 15 during the winter. It's fully safe. It's comfortable as well, unlike the previous station, which is actually fully buried under the snow. So it cannot be revamped. We are planning certain improvements, but for future research, we want our polar heroes to be accommodated in a safe and efficient environment. This new project is also now supported with a research program that has been fully elaborated. We try to glimpse into the future on a horizon of 20 years. The project is implemented under the directive of the President. So we are receiving due assistance, and in 2025, in the 70th year of the Arctic expedition, we'll begin working on the project. It has two parts. We'll continue boring wells on the Vostok Lake, where we'll be tapping the lake and studying the sediments there. Currently, our colleagues from the mining university in St. Petersburg are developing these technologies. We have been working on it for many decades now. The second part is about 300 kilometers removed from the station. At Dome B, we'll be taking core samples of ancient ice, hopefully 1.5 million years old. Dragorans to believe so. I think it's going to be one of the oldest ice samples taken from the Antarctic and generally on Earth. These projects are ongoing or ready to be launched, and we count on the support from the government. The Vostok station has continued its operation over the recent years in parallel with new construction. We got samples that are 600,000 years old, over 1 million years old as well. So we see a productive future for our upcoming plans. This is going to be a flagship project of the Russian Antarctic expedition and our presence there for the coming years and decades. It's a pioneering project. It's cutting edge, and we are hopeful for international cooperation as well, both at the station and in research. Breakthrough science relies on international cooperation, and this applies to the Antarctic as well. So I believe that our friends and partners will take part and contribute to this project. There's going to be a presentation by Mr. Shpinkov with more details on the scientific footing on this project. And then after this session, by noon, you'll get access to 3D goggles that'll give you a virtual tour around the new station. You cannot travel there physically that easily, but you can get a sense of the polar life and how it's all set up there. So in the hallway, there's going to be an opportunity to partake in polar science virtually. Mr. Makarov, that's quite a cliffhanger, and we are all excited about the Vostok station. It's a truly global event. And our president actually commissioned the station, put it online together with the president of Belarus. Could you tell us a bit more about the station for us to build some expectations of what we'll see in that 3D tour? The station has 5 modules, living quarters, labs to accommodate some of the research on site, so that we wouldn't have to transport all of the samples to here. So these labs will be equipped with proper instrumentation. As for comfort, the efficiency, we are perfectly confident that it's going to be best in class. The current station is now buried under snow, which is a very unfortunate development, which was reflected as a factor in the design of the new station. It's placed on 30-something elevated stands so that it can move relative to the snow and get a new footing on compressed snow. It's a technology know-how, and we are sure that it will prove effective. It has full life support, including living quarters, medical units, diesel generators. That's pretty much run-of-the-mill. We want to support round-the-clock stable communication with the station as well. We are working to improve it. Importantly for us, we've set up a core sample storage, a specialized facility to hold literally kilometers of ice samples. So we have a new storage, which is an important step for our invaluable samples to be properly preserved and also be easily accessible. Transporting them to here is expensive and unjustified in many cases. Storing them at the station, well, the station supports lab tests on site as well, right? Some tests, not all of them, because the climate and environment lab that we have at the Institute is specialized in core sample tests. We'll be upgrading the lab with cutting-edge equipment, and some of the samples will need to be transported, obviously. But some of the basic tests will be carried out on site at the station. Thank you. Thank you, Mr. Makarov. Let me give the floor to Vladimir Lipenkov.
Кликер, наверное.
Good morning, dear colleagues. I have only 10 minutes for my presentation. To make sure that I stick to this time frame, I have to skip some of the first slides that I wanted to use to tell you why we bore the polar ice and glaciers and why a lot of countries spent significant money to implement projects in Greenland and the Antarctic, and how the received core allows to understand the reasons of the climate change, but also to predict the changes of the climate in the future, thus preparing of the humankind to negative consequences of the climate change. Among the projects, one of the most famous projects is the drilling project at Vostok Station, which was launched in 1970 at the initiative of our institute. The main accomplishments of the project are listed on the slide. That is the deepest borehole ever drilled in polar glaciers, the first reconstruction of the content of gas and atmosphere. It's the first opening of the under the glacial lake Vostok, and the identification of ancient ice, which is more than 1 million years old. Here on the slide, you can see the information related to the core, where you can see the changes of the temperature of air, the concentration of CO2, methane, and you can see the curves of insolation calculated for the 65th degree, and the curve related to the changes of the sea level. We can speak for hours about this diagram, but what is the most important thing demonstrated by Vostok project? For the first time, we received experimental data which proved a close connection between changes of the climate and the concentration of greenhouse gases. That linkage has been observed in course of 4 climate cycles, including ice periods, periods free of ice, and so on. And the important accomplishment of the Vostok project was that for the first time they reconstructed the climate of the old era between the ice periods. It was free of ice, and all the climatologists of the world know it as the period 11, marine period 11. So the changes of the orbital parameters of the Earth that the distribution of solar radiation on the surface of Earth depends on changed, and in the course of next dozens of thousands of years, they will change in the same way they changed during those marine isotope period. So we can observe this information as an orbital analog of the era we live in right now, and we can use it in order to predict global changes in the future. This is the diagram which demonstrates the information received at Vostok station. So here you can see the isotopic content of ice, which shows changes of the temperature. You can see here the concentration of CO2 in the ice. Here you can see the ice age for period 11, and at the bottom you can see the time. So if it's positive, it's future. If it's 0, it's our time. If it's minus, it's of the past. So we use the calocynic core of the Vostok station, and we can see that for the last 25,000 of years, global changes on our planet happened according to the scenario of period 11. So if the next global changes happen under the impact of natural factors, we could speak with high certainty that in the next 16,000 years, the climate on our planet would be friendly for human civilization, the way it was during the previous 10,000 years when the civilization was formed, developed, and reached its peak. But is it going to remain like that? Most probably not. Here in this diagram, you can see the information coming from the cores, but we also monitor the content of CO2 in the atmosphere. And this information demonstrates that starting with approximately the middle of the 18th century, we have observed the growth of concentration of CO2 in atmosphere, and right now in 2024 the concentration has reached another record. It's 427 ppm in 2024, which is more than by 50% higher than what we had in pre-industrial era as far as greenhouse gas concentration is concerned. So such concentration has never been observed before. In the previous 400,000 years, 800,000 years, maybe 3 or 5 million years ago, the concentration of CO2 was like that, but the climate on the Earth was completely different back then. And we are here surprised with the speed of growth of CO2 concentration. If we take into account the isotopic content of CO2, we'll see that this increase is related to the manufacturing activity of the humankind. which means that we significantly change the gas content on the Earth. We increase the concentration of CO2. In the conditions when other climate factors and climate factors remain the same, this is the main factor which will influence global changes on our planet. This is exactly the factor which determines global warming we are observing today. Is it reflected in the Antarctic? The results of the research of small cores coming from small boreholes drilled in Vostok speak all about it. They prove that high speed of the atmosphere temperature growth was connected with more sediments and different speed of snow accumulation. So what are the perspectives of such research in Vostok? They are related with the fact that in the core received at Vostok station, we received ice which is 1 in 2 million years old. It's in the lower part of the glacier, and it does not really allow to restore the history. However, this discovery is very important because it's the first experimental proof that the ice which age is older than what you see on the screen actually exists in the Antarctic. So the climate changes happened millions of years ago. The reasons are not known, but it's necessary to research them, and a lot of national projects as well as international projects aim at its research. So here you can see the map of the Antarctic with points of boreholes where they drill to reach the ancient ice. And this map was taken from the American journal Science. It was published this year. So you can see that there are several projects related to it. There is Dome B in the Antarctic, and Dome B is unofficially assigned to Russia. Why is it so? Because the ice we found at Vostok station came from this region. It's 300 kilometers away from Vostok station. And this is where its bedding is. It was formed there, and maybe it is embedded there in its natural state without damaged stratigraphy. That's why our future plans are related to the research in this region and the drilling of the new borehole in Dome B. So here you can see the largest on Earth subglacial lake. It appeared on the map at the end of the 20th century, thanks to Andrei Kapitsa publication in Nature journal. And in 1998, the borehole reached the layers of ice which was formed under the Lake Vostok. So it was proven that it existed. Lake Vostok is a part of the huge hydrological system of the Antarctic, which includes a lot of rivers, swamps, lakes. But it's different because it's huge. So here you can see the main morphometric information about this lake. And based on the results of work of Sergei Popov, it was found out that this square of the lake is similar to Lake Ladoga. As for the volume of water, it's much bigger, more than 6,000 cubic kilometers of water. And so as far as this indicator is concerned, it's number 5 among all sweet water reservoirs on the planet. In February 2012 and in April 2015, two openings of the subglacial lake Vostok were made. So the technology was about putting the lake water inside of the bore and then drilling the water after it was frozen. We thought that these samples of frozen water would be more informative than the samples of ice that is at the upper part of the glaciers. But not all the hopes were brought to life, but with our second attempt, we managed to organize a controlled opening of this huge subglacial water reservoir. So if we sum up your presentation, you also spoke about the plans for the future. You spoke about the operations held at Vostok Station and Vostok Lake. Could you please tell us in more details about what is planned for the future? Maybe some information about future research, especially taking into account what Alexander Sergeyevich said, that now we have a station which allows to organize a lot of tests on the spot without the necessity to travel far from the lake. The program is being developed right now. It's about the continuation of paleoclimatic research at Vostok Station, Vostok Lake. It includes several projects. One of them is related to the identification of ancient ice in the Antarctic, which age is more than 1 million years. So the main stages of the project would be as follows: searching for a place to drill in the area of Dome B, the drilling itself, as well as organization of comprehensive research and tests of subglacial core. The second project is related to the research of bottom sediments, because the openings were held and they completed certain stage of subglacial lake research. But if you compare Vostok with the Moon program of the Soviet Union, then the research held in 2015 can be compared with the controlled collision between Luna 2 device and the Moon, when the flag with the Soviet Union was thrown to the surface of the Moon. And it was in 1960s, and then in 1970, the first rover was brought to the Moon. So these two events demonstrate two important stages of research. We have the opening, but we also have research, and there is a gap between them. We need to develop technologies which will allow us to have direct research of bottom sediments and lake water. We hope that we will be able to do it, and such research will be held in the facilities of the new facility, which was commissioned in January of this year. I don't have any doubts that our research fellows and scientists will be successful in this domain. So we would like to wish you success and all the best in your future work. So now we would like to hand over to Sergei Anatolievich Soldatenko. Good afternoon, dear colleagues. My short presentation today is dedicated to specific features of climate formation in the Antarctic connected to the global changes of the climate today. I would like to give you an introduction first and notions which are familiar for the majority of people present in the hall. Here on the slide, you can see the scientific in terms of what a climatic system is. Under climate of a specific region, we understand the average weather in the region. But the question is, what should we take for the period to calculate the average? According to the recommendation of international organizations, the period is 30 years. Why so? Why should we choose this period of time? We are choosing this period of time because a person during his or her life should be able to feel what is happening with the climate of our planet. Him or herself. What do we understand under the climate change? Climate change is the change of climate on Earth or certain regions, which is reflected in the changes of parameters of the system. The modern climate change is different from the previous climate changes. Paleoclimatology speaks about it. High speed, scale of changes, as well as a significant impact coming from man-made activity. Factors of climate change. So the main factors of the climate change are natural factors, and there are the so-called anthropogenic factors. So natural factors are drift of continents, changing of their relief and size, volcanic activity, shift of poles, emissions of greenhouse gases, and the mechanisms which are still not clear today, such as El Niño phenomenon, and also astronomic factors. So the main question we face today is to assess the anthropogenic factor in the modern changes of the world. The Antarctic in its role in the formation of the climate of the planet. Actually, Antarctic is a huge continent, 14 million square kilometers. The footage of Europe is 10.5 million kilometers, and the area of the US is 9.8 million kilometers, China 9.6, and the only country which is bigger than Antarctic is Russia. The Antarctic is an important climatic factor for the whole Earth. Climatic system of the Earth is a unified organism, is a singular organism. If you do something on one side of the system, it will lead to consequences on the other side. It will be echoed on the other side for sure because of the presence of interconnections, linkages, and telecommunication linkages between different regions of our planet. So here we speak about the circulation of the ocean. It's like a conveyor belt, big conveyor belt that crosses all the oceans. And you can see it on the slide right now. And this big conveyor belt forms the climate in Europe and the whole planet. Studying the climate of the Antarctic started in the middle of the 20th century, when at the continent different countries started to create permanent bases as well as seasonal stations which performed meteorological, glaciological, geological, and astronomical research. In addition to that, the impact of space on Earth is studied. About 30 countries of the world have their stations in the Antarctic today. It's necessary to mention here that our country is one of the leaders in Antarctic research, and our Arctic and Antarctic stations are one of the leaders. This institute is one of the leading organizations in the country. We have 5 permanent stations and 5 seasonal stations. Throughout many years, our institute was a key organization to implement projects related to the research of Antarctic and implementation of the national projects. Specific features related to the formation of the regional climate. That is related to the location of the area near the polar. So here you can see the comparison of where the Antarctic is located and where the North Pole is located. So what is so special about the Antarctic? It's different from the Arctic. And the main difference here is that there is a so-called circumpolar Arctic stream, which is about 30,000 kilometers long, and it's the only stream in the ocean which goes through all the meridians. And this stream is like a blocking mechanism, which doesn't allow warm masses to come to the Antarctic. Water and atmosphere included. If we have a look at the map of the northern hemisphere, you will see that the warm waters of the Atlantic and warm air from the Atlantic often come to the north. They penetrate the northern pole, making it warmer, the Arctic namely. An important factor in the formation of the Antarctic climate is aerography. Latitude is about 2,000 meters.
Указано отличие северного полушария.
This is a schematic representation of the differences between the North and the South poles, or hemispheres. This difference, which is about 20 to 80, is a major factor in determining the climate of the Antarctic, which is the coldest on the planet. Then we have the temperature increase. Current climate change is characterized by warming. Last year was the hottest on record. The global average temperature, which is one of the main indicators, exceeded 1.5 degrees centigrade. So the bottom threshold of the Paris Agreement was exceeded last year, and nobody knows what to do about it. But then you have abnormal temperatures and their distribution. It is quite evenly spread. The top picture shows the distribution of the warming in the northern and southern hemispheres, where it is quite evident that most of the warming occurs in the Arctic, while the Antarctic experiences a more diverse temperature trend. There isn't a global temperature trend for the entire planet, but in certain regions of the Antarctic, there are rising temperatures as well, even if in some regions it is on the decline. Current climate in the Antarctic is also marked by an increased frequency of heat waves. For example, in 2020, a temperature over 18.3 degrees centigrade was recorded on the continent, which is unprecedented. In eastern Antarctic, the temperature exceeded averages by 30 degrees in some areas. The slide shows isothermal lines plotted based on the observations of the Antarctic. To give you a historic perspective, the bottom chart shows that there is this phenomenon of the Arctic or polar amplification, and the temperature has risen by 5 or even 7% compared to pre-industrial levels. And there is no stable trend in the Antarctic. Climate change is also measured by specific indicators, of which we have seven global indicators determined by the WMO. The first and main one is average global temperature. The second one is the Arctic and Antarctic sea ice extent, that is the state of glaciers and ice sheets in Greenland and the Antarctic. The chart shows that the extent of sea ice in the Antarctic has been steadily decreasing over time. Here are the factors of global warming over the past decade. This is as estimated by the IPCC. They identify 5 major drivers. First, there is man-made global warming, then you have El Niño, the solar cycle, Hunga Tonga eruption in the northern hemisphere. Yeah, that would be in the south of the Pacific Ocean. An extraordinary powerful eruption in 2021-22. Last but not least, you have a reduction in marine fuel pollution. That would be sulfuric gas, sour gas from global shipping by different vessels. You have identified 5 factors of global warming. Mr. Zolotenko, you mentioned that the man-made factor is playing a crucial role here. Can you elaborate on what's the key issue here? Let me get down to it right away. Naive re-evaluation of facts or fabrication of scientific conclusions drives the transformation of climate science into a quasi-religion for the populace. Instead of providing objective data, IPCC sometimes tries to insert political statements into their reports, which is inadmissible. The academia is responsible for objective information. Everybody agrees on the man-made factor and its presence. The previous report mentioned core samples, the state of the climate dozens and hundreds of thousands of years ago. These data are not reliable enough to make direct comparisons with what we have today. I'm not trying to say that the man-made warming is negligible. I'm just saying that the evaluation of this factor and its role is the main area of research for climate scientists all around the globe. Thank you very much, Mr. Zolotenko. Mr. Lyshenkov, you're up next. Dear colleagues, hello. Let me start by saying that today Mr. Grigorov would have celebrated his 90 years anniversary. Recently passed, unfortunately, a great scientist, one of the old-timers of the Antarctic, pioneers of the pole, who laid the foundation for geographic investigation of the region. So I dedicate my presentation today to him. So a few words about the region. It includes the continent, the southern ocean. The land is 14 million square kilometers. But exposed land is 0.18%. These are mountains that amount to about 22,000 square kilometers. This is half or even a quarter of the Leningrad region here. The picture shows all polar stations, Russian and international, that provide the infrastructure for geophysical research. Here are the main avenues of research, started in 1956 with our first expedition, geological expedition, which includes on-land geophysics, geology. Again, 99% of the land area is covered with ice, so geophysics plays a crucial role in studying what's underneath it. Then, starting from 1972, geophysics came into play with technology-enabled studies. Then we have marine geology and geophysics, and this year we started boring wells with cores from the bedrock. This used to be under different agencies, the Russian Academy of Sciences in the Soviet Union, the Specialized Ministry, the Institute, the Polar Marine Geology Expedition made a contribution, and it is ongoing. The slide also shows the stations and bases that were used. And then you can classify geophysics in Antarctica into 3 stages. The first one is the heroic era. That's first geophysical expeditions, where ice thickness and sub-ice morphology were studied. Aerial magnetic surveys were done as well. The blue traces in the picture show them. This data translated into an Antarctic atlas published in 1966. It has a lot of geological information as well. The subglacier relief or terrain is present there. So we have been accumulating knowledge on what makes up the Antarctic under the ice. It's very diverse, and it shows the ingenuity of scientific exploration based on little to no data. The second stage is the Gilded Age, let's say. It's lasted for about 2 decades, wherein a number of seasonal bases were set up, as you can see in the picture. Aimery, Druzhne 1, 2, and 3. Druzhne 1 operated for 11 years, because after that the glacier separated from the Arctic, and up to several thousand of scientists were able to go there, and large expanses of space were studied. This is around where marine geophysics came in. A lot of remote sensing was done from planes. Marine seismic studies covered 21,000 kilometers. A lot of geological and tectonic maps were put together. You can see one of the first tectonic maps by Mr. Grigorev, whom I mentioned. Then there are maps of fissures. A number of scientific monographs were published based on this research. And 50% of total research in the Antarctic in geophysics was accounted for by the Soviet Union. The third stage is the current stage. You can put it somewhere around from the 1990, and the main document for us here is the Russian strategy for development of the Antarctic activities through to 2030. This includes pursuing of national interests, maintaining Arctic activities, and boosting our international prestige. In our domain, we are studying the history of formation and the potential for development in the Arctic. This shows current research. Around 150,000 kilometers of marine geophysics studies was done. In red, you see our aerial physical studies, which account for a sizable share. Starting from the 1990, our contribution to remote sensing went down significantly, down to 4%. But in the long run, we are still in the lead together in the pack of 3 pioneers. Our institute interprets and synthesizes the acquired data. The schematic shows that a set of maps, geological and geophysical, was made based on the data. It's in the red squares in the top left. In red, you have marked an area where for more than 30 years we've been carrying out research, and now finally made a geologic map with explanatory notes in the scale of on the order of 1 million. We are part of a UNESCO commission as well, which was another platform for making these maps. This slide is an example of our activities over the past 5 years, including this year. This would be 6. Green and blue are marine geophysical studies that are done by academician Karpyshin, who is now on his back voyage to St. Petersburg. On land, in brown, you have new maps where we have been tapping the data from all countries. Then you have geological, aerogeophysical studies, and starting from 2017 as well, there is a polar marine expedition where our participants take part as well, and this is in the Bengal Oasis. This year, there was a breakthrough, the first ever magnetic imaging of that area using an unmanned flying vehicle, a drone. Let me also note the Russian contribution to international projects. There is a number of such projects. AdMap is one of them, magnetic map, and you can see that the volume of data starting from the year 2000 has been on the rise. Up to 1990, the coverage was less than 1 million square kilometers of traces or profiles, and then it grew exponentially. Based on this data, our institute plotted an international map of the magnetic field in the Antarctic. Here is another project where we've made a major contribution. That's the subglacial terrain of the Antarctic. You can compare it to the map issued in 1966. Generally, it's similar, but the new one is obviously much more detailed. Another international project where we participate is IPSCO. It's now in its second iteration. Here is a geological map of Antarctic on a scale of 1 to 1 million. Another major international project where we participate. It's available digitally too. Then we are part of other international programs under the auspices of the International Committee for Antarctic Studies, Antarctic Climate Evolution, and the ice coverage of the past, ACE and PACE. So it covers the recent 100 million years, mostly 40 million years. And then this is the outcome of the French effort and the UNESCO. Mr. Grigorov offered that map as well. So he's been active as an academic through to his very last days. Onto the mineral resources. Yeah, that's what I was going to ask. Thank you. Yes. The Southern Hemisphere, India, Australia, Africa, all hold a lot of great deposits, and it's without a doubt that the Antarctic has all of that as well. But it's all covered with ice. Still, we've been able to find a lot of different things. Here are examples. Gold, kimberlites that can contain diamonds. We assume that there is a lot of iron under the ice. Coal gets exposed now. Beryls and other minerals. To conclude, I'd like to remind you of the great pioneers, academic pioneers of the Antarctic that are now commemorated on the map. Here they are. Thank you with that. A very brief question. In your estimate, what are the prospects of extracting these minerals in the Antarctic? It's prohibited as of today, but in the future, there is a convention on mineral extraction. It was drafted in the 80s, but 2 countries resigned to sign it. It requires consensus. France and Australia denied it, so there is now the Protocol of 1998 on protection of the environment. It's valid through to 2048, so it's 50 years, so nobody knows what happens after. A lot of countries do scientific research in mineral resources there, Russia as well, because We need to know what's there. We need to study the opportunities. The Chinese published just recently an article on the potential of surveying in the region. They claim that if you observe all the environmental requirements, the surveys can be not harmful, and they don't seem to be criticized too much for that. Mikhail Andreev, please, the floor is yours now.
Уважаемые участники конференции, разрешите...
Dear participants of the conference, I will try to briefly speak about the ecosystems in the Antarctic. It was already mentioned that the Antarctic continent has the square of 14 million square kilometers, and the biggest part is located under the ice. The dry land. The dry land, there's only a small percentage of dry land on the continent which is open in the summer period and is not covered with snow and ice. The Antarctic is the only continent where in the flora inferior plants, the moss and lichen prevail. There's also microbiota, microscopic fungi, algae, and there are 2 flower plants which are known. The flora on the ground is represented by isolated groups of moss and lichen mostly. The physical and geographic division is as follows. The Antarctic is divided into 3 big physical and geographical regions. Marine Antarctic, which is demonstrated in pink on the map, continental Antarctic in the middle of it, and the subantarctics. These are the islands located in the Southern Ocean. In the marine Antarctic, there are closed communities with ferial plants and namely flower plants. And here you can see the moss and lichen communities similar to what you can find in the tundras of the Arctic. Quite often there are the well-developed moss communities. In the continental Antarctic, there are 2 types of the dry land, and namely nunataks, which are located among the glaciers in the depth of the continent, as well as coastal oases. For oases and for deserts of the continental areas, we know about 150 types of plants. I mostly speak about lichen here, because lichen is the biggest part of the flora in the Antarctic. However, right now, in the Antarctic, they also study moss, algae, fungi, and other representatives of the Antarctic flora. The types of plants in communities are not very varied. In the best cases, these are 20 to 40 types of plants in one group. It's not much, just a few if you compare it to the Arctic. The moss and the lichen was collected 400 kilometers away from the pole in the transatlantic hills. So all in all, in the Antarctic flora, there are about 560 types of algae, 380 types of lichen, 137 types of moss, as well as 66 types of vascular plants, including subantarctic islands. So these are the average numbers. If you compare Arctic and the Antarctic, we can see that the square is almost the same. In the Arctic, there are 2,500, 3,000 types of lichen, and in the Antarctic, no more than 400 or 500 types of lichen. If we compare the marine Antarctic and the continental Antarctic, you will see that in the maritime Antarctic there are 400 to 500 types of lichen, but in the continent up to 100, 150 types of lichen. As I have already mentioned in my presentation, in the marine Antarctic, the moss and lichen tundras prevail, and they have the content similar to the Arctic. And there are also moss communities. In addition to that, in the maritime Antarctic, coastal Antarctic, so to say, there are such special communities of plants which consist of bright lichen. It grows where the birds are. Where the seashore colony of birds live. In the depth of the continent, the plant communities are not vividly seen. They are scarce, and mostly they consist of the lichen that hide in the cracks of rocks in closed areas where the crystals of ice or sand do not reach them. They are transported by wind. In addition to that, they get more water in cracks, and water is the main factor to develop lichen in the Antarctic. The water is frozen. It melts down over a small period of time, just for a couple of weeks, and that is the time when lichen can develop and grow. These are typical representatives of the continental Antarctic flora. Acaraspora gwini. Its size is from 5 to 10 millimeters, and often it is even smaller. In the Antarctic Peninsula, as well as in the continental Antarctic, there are such algae called Praseola crispa. From far away from the sea, it looks like it's grass growing on the rocks. But this is algae. It's algae which is characteristic to the areas where seashore colony of birds live. But if there are big colonies of birds, the plants don't grow, and there are also areas where such beautiful communities of lichen live, and it's, by the way, very attractive for tourists who travel to the coastal areas of marine Antarctic. And where the conditions are more friendly, there are the so-called meadows with grass, moss, and lichen, or such lichen tundras, as you can see on the screen, with lawn and bushy lichen. So the research of flora in the Antarctic started long time ago, 200 years ago, and in the diary of Benskausen it was written that our travelers returned yesterday from the coast and brought several rocks as well as moss and marine grass. But actually, of course, the collections started to form in our Botanical Institute only after the start of comprehensive expeditions to the Antarctic in 1955. The first collection was made in Mirny, in Bangner Oasis, later in Молодежная and Novolazarevskaya stations. All the samples came to our laboratory in Komarov Botanical Institute, which is located here in St. Petersburg, Leningrad. And they were started by the leading researchers who studied lichen of the Antarctic in 1950s, 70s. They created the basis of cryptobotanics of the Antarctic in our country. Right now, the level of development of Antarctic flora is as follows. This map is already outdated, but in blue you can see territories which are free of ice, and in red you can see the territories from where we have collections of samples. We can see that there are more territories which are free of ice, but we don't have any collections of samples from there. Here on the map you can see places from where material was collected, including by me, starting with 1988 and till present time. A unique feature of our country is that we have stations in all the sectors of the Antarctic. So it's possible to visit them, and that allowed to collect rich material circumpolarly. Thank you very much, Mikhail Petrovich. It's just amazing what you are speaking about. Such a rich flora in the most severe continent of our planet. However, if we have a look at it from the point of view of temperature, if it's plus 18, even if it's an anomalous temperature, it's clear why we have such a rich flora. But 300, 400 kilometers away from the South Pole to have such rich flora, that is just amazing and surprising. I would like to ask you one practical question. As a simple person, your research, does it have any applied character? I mean, can it be used for applied purposes? You receive fundamental knowledge with the help of your research, but can it be used in pharmaceuticals, for example, or in agriculture? Can it be used in gene engineering? Could you please answer this question? Of course, what we do is fundamental science. So we research biodiversity of lichen in the Antarctic, and we create the basis for next research. Our main work is to make the list of flora in the Antarctic. On the basis of our research, of course, it is possible to move on. For example, if we speak about lichen, econometric research allows to understand what happens with glaciers, how they decrease. If we research heavy metals in lichen, we can understand the level of environmental problems, environmental pollution. So lichen is a unique microsystem because lichen produces lichen substances, organic substances, which are characteristic of lichen and fungi. It can be used to make medicine, can be used to make colors, and right now there are attempts to use them in order to fight against cancer. I know that such research is made. Okay, thank you very much, Mikhail Petrovich. I think that we can make a small break now for 3 minutes. It's just a technical break. We are going to ask our volunteers to change the plates. And I would like to thank all the participants, and thank you very much for your presentations. Alexander Sergeyevich, I would like to ask you to stay on stage here in the panel. Thank you. And other speakers, please take your seats in the hall.